पुराने जमाने के
टीचिंग के तरीकों से
हमको क्यों पढ़ाते हैं? It's so boring.
अब वेदांतु देगा प्रॉब्लम से छुटकारा।
Hi kids.
समझ
Hello teacher.
आएगा तो मजा आएगा, मजा आएगा तो समझ आएगा।
Best teachers पढ़ाए तो simple लगे everything.
Leaderboards and quizzes से
Amazing.
learning हो जाए happening। समझ आएगा तो मजा आएगा, मजा आएगा तो
Vedantu. Learn live online. To attend a free live class, download the app now.
Hey guys, welcome to Vedantu's JEE channel. This is me, your Suri Sir, and I'm back with another exciting session of the Killer 5. Yes, the today's session, as you can see it on the screen, is thermodynamics, or also popularly known as thermal physics. So we are going to talk about all the chapters which are included in this unit, which are starting from the thermal expansion, calorimetry, kinetic theory of gases, thermodynamics, which is first law of thermodynamics, and the heat transfer. Okay guys, so let's go ahead and follow the trend. Let's see the first killer question. What you see on the screen guys, it says that you have two thermally insulated vessels 1 and 2 which are filled with air at temperature T1 and T2. So, okay, so two different vessels have the temperature as T1 and T2 filled with air. Volume is V1 and V2, pressure is P1 and P2 respectively. So the valve which is joining these two containers, if it is opened, the air will start mixing, thermodynamics will happen, temperature eventually will change. So we have to find out that the temperature inside the vessel at equilibrium will be how much. So we have to find out that temperature at equilibrium guys. Okay, so guys, when the air is considered, it's basically a diatomic gas. So if we need be, if there will be a need, we'll be trying to use the value of its Cp and Cv in this question also. Before that, let's pay attention to what exactly is happening in this question. If we look at the diagram for this question, this is what is happening. This is P1, V1 and T1. This thing is P2, V2 and T2, and then you are basically creating a gap in the containers so that the gas here and here will start mixing. Means what? The entire composition, say which was N1 here and N2 here, will mix to become the total composition as N1 plus N2. And yes, at equilibrium the final temperature will become T, and that is the temperature that we need to find out. Well, in this process, as you can see that there is no external agent involved to provide the heat to the gas, and it is thermally insulated, so there is no heat exchange happening from the surroundings. Okay, so can I say that the value of delta Q will be 0, and because the container is not expanding, so the work done will also be equal to 0. Means what guys? Whatever internal energy has to be there, it has to remain constant. So internal energy of the container 1 gas plus internal energy of container 2 gas will add up to remain the same value of the internal energy of the gas. Okay guys, so let's go ahead and try to solve this question. I'll be going to the next slide to use as a blank one to solve this question. So what we are saying that the internal energy of the mixture should be equal to the addition of the first two initial internal energies, which are U1 plus U2. Okay, now how do I write the internal energy of a gas? I write it as NCV at a given temperature. So air from the two compartments will mix. The total composition will be N1 plus N2. Because it is air in both the gases, both the containers, so that's why the value of Cv will remain the same, and final temperature is T. Similarly, I can write down U1 as N1 Cv T1 plus N2 Cv T2. So can I say that this Cv gets cancelled because for air the Cv will remain the same. So that means what guys? We have T as N1 T1 plus N2 T2 whole thing divided by N1 plus N2. So guys, if we use the ideal gas equation, we can say that N will be equal to PV by RT. So using that, let's write down the values of N1 and N2 and try to find out the value of T here. So N1 will be equal to P1 V1 by R T1 into T1 plus P2 V2 by R T2 times T2, and whole thing will be divided by N1 plus N2, which is going to be the same values which we have written here. It is P1 V1 by R T1 plus P2 V2 by R T2. So if you take R common throughout, R will get cancelled from numerator and denominator, and this T1 cancels with this T1, this T2 cancels with this T2, and let me try to simplify this thing further here. So what do I have here is P1 V1 plus P2 V2, okay, P1 V1 plus P2 V2, and in denominator, if I take the LCM, this will be P1 V1 T2 plus P2 V2 T1, and the T1 T2 will go in numerator, so like writing it there as multiplication with numerator, and the denominator is P1 V1 T2 plus P2 V2 times T1, and this looks like the correct and the final answer to the situation. It is P1 V1 plus P2 V2 times T1 T2 upon P1 V1 T2 plus P2 V2 T1. Let's have a look again, which according to option is not B and C. This one is P1 V1 T1 plus P2 V2 T2. So guys, the correct answer to this question is option A, which you can see is P1 V1 plus P2 V2 multiplied by T1 T2 divided by the term that is P1 V1 T2 plus P2 V2 T1. Okay guys, you got the method. All you had to do was conserve the internal energy of the gases in the two compartments. Cool guys. So I hope that you like the question. This is the question which is from first law of thermodynamics, and I hope that you're having fun already. Well guys, if you are finding this particular unit in general difficult when you are solving the question, then you can take advantage of something that we have for you, which we call as our micro courses. Now what exactly is a micro course? Say if you are good in a particular subject, say physics itself, and you are finding thermodynamics difficult, then instead of studying all the topics with us, you can also go with the individual chapters which you want to study at your own pace, and that is what we call as the micro courses. So with the help of micro courses, you can master any specific topic and you can prepare for any of the competitive examination. You can take advantage of our presence. All the master teachers are there, including me, to help you out, and you can solve all the questions chapter wise, including the previous year examination questions, and ask unlimited doubts and appear for unlimited quizzes with us. So if you want to go for any chapter in any subject, then micro courses are the solution for that. In order to go for that, you just have to follow this link, and very importantly, use this code SHMIC, because it's going to offer you a huge discount of 95%. Okay guys, so do take advantage of this particular micro courses which we are having there for you guys. Okay, so let's go ahead and look at the next question guys. Now what you see here on the screen is basically a composition of multiple rods, and the three rods are made up of same material. They have the same area of cross sections and have same length also. That means what? They are basically identical rods. And what is given that the left and the right ends are kept at 0 degree and the 90 degrees. Okay, so we have to find out the temperature of the junctions of the three rods. Okay, so as you can predict that the question is basically from heat transfer, and that too through conduction. Let's say that the temperature of the junction is going to be T. I'm going to give you a very interesting approach to this question. In general, when we go by the method, we write the amount of heat current as Ka T1 minus T2 by L. Yes? So you will try to write the value of the heat current, say I1 here, I2 here, and then I3 here, and then you will try to solve it by applying all the junction rules that we know. So as you know that heat transfer and the heat current can be seen very much parallel to what we have studied in current electricity, and that is the approach that we are going to go with in this particular question also. And what I'm going to do here, interestingly, I'm going to apply the nodal analysis method. Now what is nodal analysis method? It's basically a fancy way of solving some questions which can be also dealt with Kirchhoff's junction rule or KCL. Okay, so what I'm going to do now, according to the junction rule or Kirchhoff's current law, we know that I3 will be equal to I1 plus I2. You'll see that this question will be solved in very few seconds. Okay guys, so I1 plus I2 is equal to I3. How do I write current in general? We write it as the potential difference divided by the resistance, because all the rods are identical. So we'll say that all of them have the same resistance, that is R. So in order to write the value of current, instead of writing potential difference, we'll be writing the temperature difference. So for I3 to follow, the temperature difference has to be T minus 0 divided by the current resistance value, that is R. Similarly, you will write the value of I1, and I1 can be written as the bigger temperature minus the smaller one, that is 90 minus T, that is because of the direction of the current that we have taken, higher to lower potential, divide by the resistance. Similarly for the other one also, 90 minus T by R. Situation would have been interesting if the temperature would had been different for all the ends which are given in the question. So now you can see that simply R will get cancelled. So this has T equal to 90 plus 90, that is 180 minus T, which is 2T. You bring 2T here, this becomes 3T is equal to 180. Okay guys, means what? T value comes out to be 60 degree. Yes, like that we got the answer. I've chosen this question to tell you how you can apply nodal analysis method in heat current approaches in the questions which are related to conduction as well. Okay guys, I hope that you like the approach of the question, very similar to what we can solve many questions and use this method in current electricity as well. Okay, cool. So let's go forward. Let's have a look at this one. Yeah, a very lengthy question, and usually I've always said this, that lengthy questions are the one which are actually very simple to solve. So guys, what is happening in this question? It says that there is some gas which is being filled here. Initially the heater is off, this platform is fixed, and the spring is in its natural length, and what you see here in between is basically a movable piston. This thing what you see here is movable. It can move left and right. So what happens now? You switch on the heater. So when you switch on the heater, the gas which is there inside starts to get heated up. Its internal energy starts to increase. And we know from our first law of thermodynamics understanding that delta Q is equal to delta U plus W. Yeah. So when you are supplying heat to the gas, its internal energy will increase, and it will also try to do some work by expanding itself. So what will it do? It will basically try to apply a pressure over here. So it will create a pressure, and basically because of that pressure there will be a force exerted. So that force which will be exerted by the gas pressure here, guys, will make this platform move to the right and effectively compress the spring. So in that process, the question tells us that the piston moves by this amount, that is 0.1 meter, and because of this movement of the piston, the spring also gets compressed. Okay, so when this is happening and the system attains its equilibrium position, we have to calculate the final temperature of the gas. What is given to us is the area of cross section of this platform, which is 8 into 10 to the power minus 3 meter square. The initial temperature of the gas has been given, the volume of the gas initially has been given, and its initial pressure has also been given as the atmospheric pressure. Okay, so let's go ahead and try to find out what is going to be the final temperature when the system will have this much amount of expansion in the gas container, and you can say the compression in the spring. So let's go ahead and try to solve this. We'll have to keep on coming back to the slide to use the values. Okay, cool. So that is basically the system. So when this will be moved by a distance x, say when this is moved by a distance x, then obviously there will be a force which will be created by the spring, and obviously there is atmospheric pressure which is already present from the outside. So if we try to write the value of P1, which is given as 1 into 10 to the power minus 5, now the pressure P2 will change. what will that pressure be? First, that pressure will obviously be equal to P1, which was already there, plus P1 is basically from the atmospheric gases outside, and the other pressure which is being created is basically because of the spring force. So that's why Kx by A is going to be this pressure. Okay, so let's calculate that value itself. So this is basically 10 to the power 5. Sorry, this is plus 5, and K value has been given to us as 8000. So this is 8 into 10 to the power 3. X is 0.1, that is 10 to the power minus 1, divided by the area. That area is given as 8 into 10 to the power minus 3. So 8 into 10 to the power minus 3, which means what? P2 will be equal to, this 8 gets cancelled, this is 10 to the power 2, this goes up, becomes 10 to the power 3. So 10 to the power 2 plus 10 to the power 3 is 10 to the power 5, which means P2 is 10 to the power 5 plus 10 to the power 5, which is 2 into 10 to the power 5 Pascal. Okay, this is also in pascals. We have initial and the final pressure with us. Also, initial volume, if we speak about, the initial value of the volume is given to us as 2.4 into 10 to the power minus 3. So this is 2.4 into 10 to the power minus 3 meter cube. And now the new volume will be equal to the initial volume plus the amount of volume by which this has expanded. So A into X. So if we talk about A into X, the area is 8 into 10 to the power minus 3 of this piston, and X is equal to 10 to the power minus 1. Okay guys, that means what? We can say this is equal to 2.4, 8 into 10 to the power minus 1 is 0.8, taking 10 to the power minus 3 out, which gives me the final volume as 3.2 into 10 to the power minus 3 meter cube. Okay guys, now initial temperature has also been given as 300 Kelvin. Let's call it T1. So we have P1, V1, T1, and we have P2 and V2, and we do not know the value of T2, which is the final temperature of the gas. But what remains same is the amount of gas which is there inside, because gas is not leaking. So what we can say that in both the situations the number of moles will remain conserved. So we can say that number of moles will be P1 V1 upon R T1 equal to P2 V2 upon R T2. So you can see that R gets cancelled throughout, so no need of writing it down here. Okay, cool. So let's simplify this. For the value of T2, we can say that T2 will be P2 V2 T1 divided by P1 V1, and let's write down the values now. Okay, so P2 is 2 into 10 to the power 5, V2 is 3.2 into 10 to the power minus 3, and initial temperature is 300. Dividing it by P1 and V1, initial pressure is 10 to the power 5, initial volume is 2.4 into 10 to the power minus 3. So you can see that 10 to the power 5 is easily cancelled, 10 to the power minus 3 is cancelled. This is 32 by 24. So you can say that this is basically going to get cancelled by 8 4 times. This is 3 times. So what you have so far is 2 into 4 into 300 by 3. So this cancels it 100 times. And your final answer for T2 guys comes out to be 2 4s are 8 multiplied by 100 as 800 Kelvin. Means what? When the gas which is receiving the heat from this heater, when the temperature of the gas will become 800 Kelvin, by that time the piston will be moved by 0.1 meter, or you can say the spring will get compressed by 0.1 meter. Okay guys, so what we did, we conserved the mole by after finding the values of P2 and V2. Okay, I hope that you liked the question. The question is basically from Okay, it's not a JEE question though, but yes, the correct answer to the question comes out to be option B. Hope you like the question. Yes, it is a killer question. Yes or no? Cool. Next one. Now this is a JEE question, JEE 2014 one, and let's have a look at the question. What does it say? It gives you the information about a gas which is being taken through this cyclic process. So this cyclic process is A, B, C, D. The values of pressure change and volume change is also given to us. Question wants us to find out that if this is a monoatomic gas which is being taken through this cycle, then the amount of heat that is extracted from the source in a single cycle. Amount of heat extracted from the source, which means what? Amount of heat that is gained by the gas is to be calculated here. Okay, do not think that the heat has been extracted from the gas. Heat is basically being taken from the surroundings by the gas, or whatever is the source of heat. From there, the heat has been taken by the gas. So in this process, every cyclic process has parts where the heat is basically being extracted from the gas and the parts where the heat is being given to the gas. Let's first figure out which are those parts where the heat has been given to the gas, and simply we can say that where delta Q is going to be positive is what we are basically trying to find out. So when you are looking at A to B, what is happening? Gas is expanding, and if you look at the value of PV, this is basically 2P0 V0. This is 2P0 2V0, that means 4P0 V0, and this point is P0 times 2V0, so this is 2P0 V0 and this is P0 V0. Okay, so when the gas is going from A to B, you can see that the gas is expanding, so yes, work done is positive. And because P0 V0 pressure and volume both are increasing, so PV equal to nRT, T has to increase, which means what? Delta U is positive because temperature is increasing, work done is positive, that's why work done is also positive because the volume is increasing, which means what? In A to B process, the gas will be gaining heat. Okay, so delta QAB will be positive. So one of the parts where we need to find out the value of the heat which is absorbed by the gas. Okay, from B to C, what you see? P0 V0 is decreasing, which simply means what? First of all, the pressure is decreasing and volume is kept constant. So even if we go by PV equal to nRT, you can see that when we are talking about this, volume is constant, so no work is being done. It's an isochoric process. Volume is constant means pressure is directly proportional to temperature. Pressure is decreasing, so temperature will decrease. Work done is not happening, temperature is decreasing, so that simply means decrement in the internal energy. So the heat for that part, that means delta Q for B to C is negative, not something that we want. Okay, moving on from C to D, further see that pressure is kept constant and volume is decreasing. When volume is decreasing, work done is surely negative. And when pressure is constant, when P is constant, V is directly proportional to T. And if volume decreases, temperature decreases, that simply means apart from work done being negative, when temperature is decreasing, the internal energy change is also negative. So we can say that Q from C to D is also negative. Now we are left with one more part, that is D to A. Here the volume is constant, so no work is done. You can see that pressure is increasing, and if pressure increases, temperature increases. That means internal energy is the only thing which is mattering here. So Q from D to A is also positive. So what are the paths that we are interested in? We are interested in this one and we are interested in this one. These are not the part that we are interested in. And if we go by this graph, basically this is the part where heat will be absorbed by the gas. So let's go ahead and try to calculate the value of the heat which is gained by the gas in process D to A and A to B. Okay, so let's go and solve this. Cool guys, so now we'll be focusing on DA and AB path. So when we are talking about say QAD, in this path, because the gas which has been mentioned to us is a monoatomic gas, that means for a monoatomic gas, we know the value of CV will be equal to 3 by 2R and the value of CP will be equal to 5 by 2R, because we are going to need this, okay, because the processes are isobaric and isochoric both. As you can see, from D to A, when we are taking the gas, the process is isochoric, the volume is constant, so no work will be done, and this can be calculated as NCV delta T. If I put the value of CV, that is 3 by 2 NR delta T, it is going to become. So that's basically the amount of energy that it is going to have. Okay, cool guys. So this is 3 by 2 nRT. If I speak about A to B, then it's an isobaric process. So it is NCP delta T, and the value is 5 by 2R. So this is 5 by 2 NR delta T. So can I say that total heat which is gained by the gas will be QDA plus QAB, which is 3 by 2 NR delta T plus 5 by 2 NR delta T. So you cannot directly just get to the answer, reason being the options are in terms of P naught and V naught. So what I'll do, I'll just write it again. This is P naught V naught, this is 2 P naught V naught, this is 4 P naught V naught, and this is 2 P naught V naught. Okay guys, so instead of writing it in terms of NR delta T, let's write it as P1 V1 minus P2 V2, or final minus initial value. So 3 by 2, the final value is 2 P naught V naught, initial is P naught V naught, so this is 2 P naught V naught, this is P final into P final V final, P2 V2 minus P1 V1 is what I'm writing. So finally it is 2 P naught V naught, initially it was P naught V naught, plus 5 by 2, and this change is 4 P naught V naught minus 2 P naught V naught. Okay guys, so what do you get? You get it as 3 by 2, this is P naught V naught, plus 5 by 2 P naught V naught. Now LCM is same, so this is 3 P naught V naught, this is 10 P naught V naught. That means the answer comes out to be 10 plus 3, 13 by 2 P naught V naught is the total amount of heat which is gained by the gas from the source, which according to options is option C. Okay guys, I hope you liked the question from JEE 2014. Okay, now this one is the 5th killer question of the day. Now according to this question, read the question. It says that we have a ring shaped tube, so it's a tube which contains two ideal gases with mass and molar masses M1 that is 32 and M2 equal to 28. Well, they have equal mass basically. That part has been missed here. They have equal mass and molar masses are in the ratio 32 and 28. And the gases are separated by one fixed partition and another one is a movable partition, that is stopper S. Okay, so we have this partition which is fixed and this can move left and right as per the change in the pressure of the gas. So there is no friction while this partition S is moving, so there is no energy loss happening. So because at the given instant the angle is given as alpha, the question is asking us to find out that what will be the value of alpha here. So in this tube guys, explaining it one more time, this partition is fixed and this one is movable. When do you think S will be in equilibrium? Yes, when the force which is exerted from this side and from this side will be same. So we can say that force will be same when the pressure exerted from that portion to this portion is going to be same. This portion say has a volume V2 and this portion has a volume V1. So we are saying that when angle alpha will be made, the situation is when this partition will be in equilibrium. So for equilibrium condition, can I say that forces will be equal on both sides and so will be the pressure? And if pressure is same on both the sides, we can use the ideal gas equation to write the pressure term, and we can write it as nRT by V. So this becomes N1 R T, because finally at equilibrium the temperature will also be same. So N1 RT by V1 will be equal to N2 RT by V2. So RT gets cancelled, and now what you have is number of moles by volume ratio being equal. Number of moles can be written as mass of the gas divided by the molecular mass, and as I said, the masses are equal, so you will write it as M divided by M1 V1 equal to M divided by M2 V2, which means what? When you cancel this, M1 V1 is equal to M2 V2, so we can say that V1 by V2 is equal to M2 by M1. Okay guys, so we have the ratio of available values of M2 and M1, so we can calculate the value of the ratios of volume V1 and V2. So when we get that, the volume ratios are going to be M2 by M1, which is 28 by 32 or simply 7 by 8. Now guys, let me think about the process that how will I calculate this alpha. Can I say that the entire volume of the tube which is filled is corresponding to an angle that is 360 degree? That means V1 plus V2 is equal to 360 degrees, and V2 is going to be corresponding to that angle alpha, and V1 for the remaining 2 pi minus alpha angle. So somewhere I need V1 plus V2, because that is where I'll be able to boil it down as well as pinpointedly be able to say that V1 plus V2 is corresponding to an angle 2 pi or 360 degrees. So what I'm going to do now, I'm going to add 1 to both the sides, so that now we get in numerator as V1 plus V2, in denominator is V2. I'm not doing it V2 by V1, reason being I want it for V2 because that is the angle alpha that we are looking for, and this becomes 15 by 8. Okay, so now as I said, V1 plus V2 is corresponding to an angle how much? 360 degrees, and V2 is corresponding to an angle alpha. I hope that you are getting this part. This is where the question gets killer. The entire volume of the tube is corresponding to 360 degrees, and only V1 portion volume is going to be corresponding to the portion that is alpha. Okay, now guys, just need to find out the value of alpha here. So to calculate alpha, we have 360 degrees multiplied by 8 divided by 15. You will cancel this 24 times, multiply this, you'll be getting it as 192 degrees, and that will be the answer to this question, guys. I hope you like the question, because this is one of my favorite questions from today's Killer 5 sessions. Okay guys, well, so this was a question from JEE 1997, that too from the subjective part of it. Okay, I hope that you have liked the session today, as always you do. Well guys, there is one more thing that I want to tell you. I want to actually thank you all for making this Vedantu's app as one of the best app of 2019. Thank you for giving us the User's Choice Award for 2019, guys. And if guys, you are one of those who are still not there on our app, then I think this is the high time that you go on your Play Stores of the cell phone, download the Vedantu app, and take the advantage of the immense knowledge which is available on this platform. Okay guys, so and on this note, I'll take your leave. I'll be back again with another exciting session of Killer 5. Till then, keep solving all the questions which we are solving on the session. Apart from that, you can refer our content from our other channels, from our other playlist which is there, like JEE Sprint is also there. Yes, one more thing which I forgot to tell you. All the micro courses which are related to thermal physics, which means everything which is related to thermal expansion, calorimetry, KTG, first law of thermodynamics, and the heat transfer. All those links for the micro courses are available in the description. So do take the advantage of all those courses. Go to the app, download the app, and subscribe for all the courses which you want to go for. And then I'm sure that you guys will be able to reach to your maximum potential. Okay guys, on that note, I'll be taking your leave. And if you have not, like, share and subscribe. Tell your friends. And if you have not subscribed yet, subscribe to the channel, guys. I'll see you again very soon. Till then, bye-bye.